Okay, a particle P moves in a straight line with velocity function vt, so velocity as a function of time, equals t squared minus 3t plus 2, and it's measured in meters per second. So answer the following without a calculator. Part A, how far does P travel in the first 4 seconds of motion? Part B, find the displacement of P after 4 seconds. So what really matters here, so for part A, we need to know what direction the thing's travelling in. So yes, we can get an expression for displacement by integrating the velocity. We will do that. But what's really important, you need to know basically what the particle's doing. So if we start with this Vt, that equals t squared minus 3t plus 2. So if you look at that, it's quite a nice friendly quadratic that will factorise. So if factors of 2 and 1 have got to be the same sign to make a positive. So if it's minus 1 and minus 2, that will work. So that means if we sort of try and draw a sign diagram, you know you're going to have zeros So if we try and draw a sign diagram, you know you're going to have zeros at 1 and at 2. So this is time along here. And we're doing a sign diagram of Vt. So it's a positive quadratic, so it's going to kind of come around like this, which means it's going to be positive this side of the 1, then it's negative between 1 and 2, and then it's positive again, right? So we are only interested in from 0 onwards, so nothing, negative times don't exist in the contents of the question. So it kind of stops at 0 really, so 0 here. So basically what that means is it's got a positive velocity from the beginning, from no second to 1 second. Then it has a negative velocity between 1 and 2 seconds. That means it's going backwards. And then it has a positive velocity from 2 seconds onwards. So this particle, it kind of starts going forwards. Obviously, yes, it's all on one straight line, but I'm going to kind of draw it with a little wiggle just so you can actually visualize it. So it starts off going forwards, and then it turns around, and then it goes forwards again. So that happens. So it begins at t equals 0. And then it turns around when t equals 1. So between 1 and 2, it starts to go backwards. So this must be t equals 2. And then from there, it starts going forwards again. And we're really only interested in up to t equals 4. Okay, so that's the basic motion diagram. I haven't been asked for it, but without it, you're going to really struggle to answer part A without a calculator. So what now, I think it'd be quite good to have an expression for the displacement. So you know that s of t equals the integral of Vt with respect to time. So the displacement function is the integral of the velocity function. So that must be the integral of t squared minus 3t plus 2 dt. So that must be t cubed over 3 minus 3t squared over 2 plus 2t, and we do need to consider the constant of integration. So this is our st. I'm going to put a ring around that, so we're going to use that quite a lot. So really we're going to need some key values. So we're interested in s, so the displacement at t equals 0, at t equals 1, at t equals 2, and at t equals 4. If we have all those things, then we should have enough information to work out A and B. So what we're using this kind of displacement. We're using this fact that displacement can be, or displacement between 2 times is the s at t2 minus s at t1. So that tells us total displacement between those two things. So we need to, for part A, we need to take into account the direction as well. This is what we're going to be using. So for part A, we're going to split the thing up to in these three different journeys, from 0 to 1, from 1 to 2, and from 2 to 4. So before I do that, I'm going to get these key values. So S of 0 equals, well, S of 0 should be easy. It's 0 cubed over 3 minus 3 times 0 squared over 2 plus 2 times 0 plus C. So that's just C. S of 1 is going to be, well, it's 1 cubed over 3, so that's 1/3, minus 3 times 1 squared over 2, so that's 3 over 2, plus 2 times 1 must be 2, plus C, so that's not quite so nice, is it? So that is going to be, put it all in sixths, so 1/3 must be 2/6, 3 over 2 must be 9 over 6, 2 over 1 must be 12 over 6, plus the C. So S of 1 equals, well, it's 12 minus 9 is 3, plus the 2 is 5, so it's 5 over 6 plus C, so that's quite useful. S of 2. S of 2 equals, so it's going to be 2 cubed over 3, so that can be 8 over 3, minus 3 times 2 squared over 2. 2 squared is 4, 4 over 2 is 2, 2 times 3 is 6, so that must be minus 6, and plus 2t, well, 2 times 2, sorry, is 4 plus the C. So S2 equals, well, it's 4 minus 6 is minus 2 plus 8 over 3. So minus 2 must be 6 over 3. Minus 6 over 3 plus 8 over 3, which will give us 2 over 3 plus C. So S2 is 2/3 plus C. And S4 is going to be 4 cubed over 3. So 4 cubed is 64, 64 over 3, minus 3 times 4 squared over 2. So 4 squared is 16. 16 times 3, 48. 48 over 2 is 24. So minus 24, which must be 72 over 3. Plus 2 times 4 is 8, which must be 24 over 3. Plus C. So 64 minus 72 must be minus 8. 24 minus 8 is 16, so this is 16 over 3 plus C, and I think I'll probably leave it at that for now. So S4 equals 16 over 3 plus C. Okay, so now we've got these 4 useful pieces of information, we can then start to actually answer the question. So part A, how far does P travel? So we're looking at total distance in the first 4 seconds. Well, in the first second, it travels, well, this distance, so the displacement when t equals 1 minus the displacement when t equals 0. So it's going to be S1 1 minus S0. That's the first bit. Okay, and then from t equals 1 to t equals 2, this is negative, so we're going to be minusing, and that's going to be S2 minus S1, like that. And then we go from 1 to, So we've been from 0 to 1 and from 1 to 2, and then we've got to go from 2 to 4. So that's going to be plus S4 minus S2. So the first thing, does anything cancel off? And I think potentially the S2s are, unfortunately, they're both negative, so that's not great, is it? S1 minus S1 isn't very helpful either, and you've got an S4. So you end up with S1 minus S1, so that would be 2S1 minus S0 minus 2S2, and then plus S4. So that must be, well, S1 is 5/6 plus C, so 2S1, actually now might be as good a time as any to make this third, so 2S1 must be 5/3 plus 2C, so 5/3 plus 2C minus, there's just one S0 which is just C, minus 2S2, well S2 is 2/3 plus C, so 2S2 could be 4/3 plus 2C, so minus 4/3 plus 2C, I'm going to put minus 2C because I'm not having a bracket, so minus 2C, and then I've got plus S4, S4 is 16/3 plus C. So hopefully the C's are going to disappear at least. You've got a plus 2C and a minus 2C and a minus C and a plus C. So then you end up with 5/3 minus 4/3, which is 1/3, plus the 16/3, which must be 17/3, which 3's into 7, well 3 5's are 15. So it must be 5 and 2/3 equals 5 and 2/3 meters total distance travelled. Okay, so that's part A. So for part B, it should be a lot easier. It's just asking us the displacement after 4 seconds. So it's basically asking, in those first 4 seconds, what's the overall change in position? This displacement just means how far has the position changed. It doesn't matter that it's doing this and doing this and doing this. It's just saying where did you start and where did you end? What's the difference between those 2 points? And it's only motion along one line. So it's literally final position minus starting position. So it's going to be S4 minus S0, and S4 is 16/3 plus C. S0 is just C minus C, so the C's disappear. So we just have 16/3, which is, well, 3 5's are 15, so it's 5 3's plus 1 left over, 5 and 1/3 meters to the right. Oh, I should have, yeah, meters. And because that is positive, so it's asking the displacement, basically it could be negative, as in you're left of where you started, or if it's positive, it's right of where you started. So I'm going to put to the right if I can fit it in.